and disappear. Okay? So you see in the animation block, myView.alpha equals 0. That means fully transparent. Okay? So that is whatever it's at now. Okay? It could be anything. It's going to go from whatever it's at now to 0 in 3 seconds on screen. Okay? But in the code, this happens immediately. Immediately, the view has gone to alpha of 0. It's just that on screen, it's not showing what's currently the state. It's showing this animation. Okay? And notice the completion handler there. Okay? The argument to the completion handler's block is a bool that says whether the animation finished. Why wouldn't this animation finish? Well, some other animation might start animating alpha, or someone might just set alpha. So if anyone interferes with alpha, then the completion handler will get called. This animation will get interrupted. The completion handler will get called, but the bool there will be no. But if nothing interrupts it and the alpha goes all the way to 0, then this completion handler will be called and the argument will be yes. Yes, it completed. And if that happens, I'm then going to remove my view from the view hierarchy. So what this single line of code does is fades out my view, and if it successfully fades it out, removes it from the view hierarchy. Question?
If you, in the next line, did kind of the same thing except change the alpha to something else, and you had the delay equal to 3 seconds, it seems like it's right on the edge there. Maybe it happens after this one finishes, or maybe it happens before. Is there?
Yeah, so the question is, what if I have another animation that I execute on the very next line? Well, first of all, let's say I delay this one, right? So you're saying delay this first call, put delay in there, delay equals 3 or something?
Actually, delay the second one so that it happens.
Okay, so delay the second one exactly 3 seconds. Okay, so that'll be fine because the first one will finish instantly right before the second one starts. Okay, because it's a common practice to do exactly that. Have something take 3 seconds and then start the other one with a delay of 3 seconds. So yeah, it'll work. Here's another, oops, I guess I didn't do that example. But anyway, so that is, everyone understand what's going on there? It's really that simple. The main thing to understand is that that alpha would be set immediately to 0. It's just on screen that it'll show. All right, let's talk about some of the options. The first one's an interesting option, begin from current state. So if you set this option on, okay, in the options list, what this means is if there's another animation that's going on that is animating the things I want to animate, then pick up from wherever they are when you do my animation. Okay? So if I'm doing that alpha thing and it's fading down and it's down to 0.2 or something, and then I issue another animation to start that goes up to 0.7 alpha, if I have begin from current state option on, then it'll start at 0.2 and go up to 0.7. If I don't have this on, it'll start at 0 because 0 is what the real alpha is and go up to 0.7. So begin from current state is a way of intercepting other animations, intercepting them, right, in mid-flight. Okay? Because you need this because remember that when you set these animation parameters, it happens immediately. So if you want to intercept an animation on flight, you need some option for the system to go check and see where the view is if it's flying across screen before it sends it to a new place, or if it's fading out, it fades it to a new level. It's very common to have that option on, actually. And then you can see things like allow user interaction. Do you want to allow gestures to happen in this view while it's in flight? Sometimes that makes sense, sometimes not. Down at the bottom, you see those curves, curve ease in, curve ease out. Sometimes when you move a view across screen, you don't want it to just up and move. You want it to kind of slowly pick up speed, get up to full speed, and then slow down at the end. It's a little smoother kind of animation than just, here's my view, that's a little, you know, but, okay? Better, smoother. So curve in, ease and out, that's for controlling that. Okay? Same thing for fading. You could do it for fading as well, though fading tends to be okay linear. But moving, definitely, curving in and out is a pretty good idea. So you can look in the documentation, see what all these options do. You can repeat animations, have them go over and over, and things like that. So, so that's how you animate those special properties, okay? And it animates them. It figures out all the in-between. Even if you animate multiple of them at the same time, it's moving, it's fading, it's rotating. It'll interpolate all those points all the way along automatically. Okay, and pretty high performance as well. Okay, sometimes though, you're changing your contents of your view in a way that's other than those 3 things. The classic example here, the playing card. When I'm flipping my playing card over, the only property I'm setting in my view is face up equals yes, right? And now my card flips over to face up. Face up equals no. Now it flips over to down. So that's not an animatable property per se. However, what I'd like to do is have the view change from face up to face down through some animation, like flipping the card over or dissolving between the two. In other words, I want to change the entire view through some animation to a new state. And that's what this one is for, transition with view. So transition with view takes a view that you want to do, like a playing card view, and it takes a duration, how long it's going to take to go from the old state to the new state. Options, again, similar to the other options, but this is especially where you would specify the options listed at the top there, like UIView Animation options transition flip from left would mean I want this to flip over, or cross dissolve. I want to cross dissolve or curl up. And then animations, again, is a block. That's where you're going to set face up. Okay? In that block, you can set anything you want about the view to make it be in its new state. And the system will apply all those changes, redraw the view in the new state off screen, and then transition between the two. The old state that's on screen now and whatever your changes result in. Make sense? Questions about that? And then completion, same thing. If you get interrupted somehow, you know, it's harder to get interrupted on this one, but it can happen. Then the completion handler gets called, either way. Okay? So this one will be great. Part of your homework is to flip that card over, and this is the method you're going to want to use. All right? So very, very straightforward. If you're changing the view hierarchy, like you're swapping a view out, okay, you got a view in the view hierarchy and you're swapping a new one in, or if you want to hide a view in favor of another view, you can use this transition from view to view. So this one is kind of like the other one in that you're changing, but instead of having a single view that you're changing its state and then flipping it over, here you're replacing a view with another view. Okay, but otherwise it's very similar. It's even called almost the same thing, transition, right? Transition from view to view. Okay? All right. So that's it for direct changing of views, properties, and making things happen. Okay? The next kind of animation we're going to talk about, which is a totally different system, new for iOS 7, is called dynamic animation. And this one's a completely different concept. Here what you're going to do is define a bunch of physics that apply to all the views that you want to animate, and then you're just going to say, okay, do it. And they're going to go have those physics applied to them. So what kind of physics are we talking about here? We're talking about gravity, collisions, forces applied to them, things like that. Okay? And that's they're just going to keep on animating until the forces all balance out. Okay? And we'll see what that looks like. The way we do this is a really nice API, very easy to use. You create a UI dynamic animator. You just need to create one. You can do multiple, but this one, it's really for grouping these behaviors, but usually we create one dynamic animator with alloc and init, basically. I'll show you that. And then you're going to add behaviors to it. Behaviors are like gravity, collisions, pushes, those kind of things. Those are behaviors, things that are going to be applied to the things. And then you put the things in there. And the things you put in there are UI dynamic items, meaning they respond or they implement that protocol. I'll show you that. And the instant you put them in there, they'll start animating. You don't have to say run. You don't have to do anything. They'll just immediately. Anytime there's an item that's in a behavior, that's in a dynamic animator, it will start animating until the forces on it mean that it doesn't need to move. Then it'll stop. Okay? So let's look at all these things. UI dynamic animator, you can just do alloc and init, but when you're doing views, if it's views that you want to animate, you want to do alloc init with reference view. Okay, and init with reference view, you're specifying the top view of a view hierarchy. All the views you animate have to be in that view hierarchy. In other words, they have to be somewhere a subview of this reference view or a subview of that or a subview of that, as deep as you want to go. But you have to specify the top level view. Okay? Then you create these behaviors. The behaviors are just alloc init, like UI gravity behavior alloc init, UI collision behavior alloc init, and then you add these behaviors to the animator using add behavior, which is a dynamic animator method. Okay? Couldn't be simpler. And then you add the items to the behaviors, and you do that with add item in dynamic behavior. So An item is just an ID that implements the protocol UI dynamic item, which you can see there below. And again, UIView implements that protocol. So usually the items we put in there are UIViews about 90% of the time, 100% of the time in this class, 100% of your time in your homework. I'm only asking you to animate views. But you could animate completely non-visual items. They could be, as long as they implement this protocol, they can do anything they want. So what's in the protocol? There's the bounds. That's, again, the bounds in the items world. It's like the views bounds, right? It's its own drawing coordinate system. Notice that's read-only. Okay? It could be modified by the transform, centering, moving the thing around, possibly, mostly the transform. So the bounds, though, is just the drawing area for the item. But the center, in other words, the position of the item, and its transform, its rotation and scale, those are read-write. Those can actually be set. They're obviously set by the animator. That's what the dynamic animator does, is go figure out what the center and rotation and scale should be. And you can set them too, but if you do set them while the animator is also setting them, you have to call this method update item using current state in the animator, or otherwise the animator will ignore anything that's going on, okay? So if you want to be setting the center, if you want to be moving the thing while the animator is also trying to move it, in other words, you want to fight it a little bit, or if it's moving it and you want to rotate it, you need to do this update item using current state. Otherwise, it'll assume, for performance reasons, that it knows the current state until it's done animating, until everything settles. Okay? So that's it. Animator, behaviors, and items. That's all there is in this system. So now let's talk about some of these behaviors, the concrete behaviors that are available. There's gravity. Okay, gravity behavior by default, gravity is down. So if I'm holding my phone, it's down, which kind of makes sense. If I hold my phone up, I kind of want things to go down. But really, it can be set to any angle. You can have the gravity up or to the left. You can have multiple gravity pulling on things from different directions. In fact, if you had two things pulling, one from the top, one from the bottom, the thing would just float in the middle if they are the same magnitude of gravity. And you can set the gravity. A magnitude of 1 means 1,000 points per second squared. That's the acceleration due to gravity. Okay? That feels a lot like 9.8 meters per second squared, which is acceleration due to real gravity. So in other words, if you hold your phone up and let the gravity work, it kind of feels like it's falling about the same speed something in real life would happen. And it's also a very nice round number, 1,000 points per second squared. Okay? But everyone understand, it's just like gravity. It's an acceleration in a certain direction. Collision is really cool. Collision just means the items inside of the collision behavior, if they bump into each other, they'll bounce off each other, like a real-world collision. And you can specify the elasticity and how bouncy they are, and that even you can define the density of one versus another. So a really dense one will smash another one out of the way. All definable. You can also set boundaries. So any UI Bezier path that you want to come up with, you can put it in your collision behavior, and things will bounce off it. So it could be round, it could be square, whatever, and things will bounce off it when they hit it. Also, you can set the boundaries of the reference view to be bouncy boundaries as well by saying translate reference bounds into boundary equals yes, and then things will bounce off the edges of the reference view, the top level view in the dynamic animator. Okay? So the collision mode determines whether the items bounce off each other or just off the boundaries. Okay? All right. Attachment behaviors. Okay, this is a way to attach an item to a fixed point or to another item. Now, one thing to remember about this, if I hook an item up to a point, that does not mean that item's not going to move. Okay? If I hook it up to this point and I have an item here, right, and gravity happens, my item's going to go like this. It's going to swing, okay? Because the attachment is just attaching the two things, the point and the item. It's not attaching it to the background, okay? And also, if I